Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll describe null hypothesis significance testing for multiple regression with the full model. So we'll just talk about statistics for the full model, the overall model in this video lecture. So the general steps for null hypothesis significance testing with multiple regression, we go through all of the same steps as we usually do for null hypothesis significance testing, but essentially this is a flow chart of how we progress through looking at the overall model and then the unique predictors. So the first thing we do is we test the full model. So we include all of the predictors of interest. In our smoking example, we have 2 predictors. So we look at the test of the full model, the F test, the omnibus F test, and if P is larger than 0.05, then we stop. And we say that the predictors did not significantly predict our outcome. But if the test of the full model is significant at p less than 0.05, then we go on and test the unique effect of each predictor. And I've included a double-headed green arrow here to show you that we can do one or the other if we don't have some conceptual reason for looking at one predictor over another. Just select arbitrarily whichever one you would want to look at first. But the idea is that we then look at the unique effect of each predictor. And that's what we'll talk about in the next lecture. So for testing the full model, we use the F statistic. And I talked about the F statistic when we looked at simple linear regression. But the F statistic is the mean square regression divided by the mean squares residual. So the F test evaluates whether the cumulative effect or the total effect of both predictors is 0 in the population. So does the set of predictors account for a significant amount of variation in the overall outcome? So the null hypothesis would be that the R square is equal to 0, that there's a negligible amount of variation accounted for in the outcome by the predictors. The alternative hypothesis would be that R square is greater than 0. And remember, R square ranges from 0 to 1 because it's the amount of variation accounted for. So it can only be 0 to 100% or 0 to 1.00. So if the R square is greater than 0, then we have accounted for some amount of variation in the outcome with our sets of predictors. This is all our alternative hypothesis for the full model. So if we think about the hypotheses as statistical models, we again are just hypothesizing that there's essentially no effect of the predictors on the outcome, and that the predictors then, therefore, the scores on the outcome do not vary with the predictors in any systematic way. So what that would look like for our 3-dimensional regression plots is that would just be the flat plane that represents the grand mean. And that's this plot on the left. For the alternative model, we now have specified in the model that there is some effect of each independent variable on the outcome. And so we represent this model with the regression plane. So this is our alternative model. And so we want to see which one is true, right? These are our hypotheses for the overall models. So is the plane flat for the 2 predictors influencing the outcome? Is there no influence? Or is the plane, the regression surface, tilted in one way or another? Meaning, do the scores systematically vary? So again, the F test for the full model is evaluating the set of predictors and whether the set of predictors taken together explains variation in the outcome. So the F statistic, if we recall, has 2 sets of degrees of freedom, and the first one is the number of independent variables, which is 2, and the second one is n minus 1 minus the degrees of freedom for the regression, which is 2. So our overall degrees of freedom there would be 12 because we had 15 people, minus 2 predictors, minus 1. And the F statistic is equal to the mean square regression divided by the mean square residual. And here that F statistic is 6.28 for the smoking example. The F statistic is significant, and the significance implies that at least one predictor exerts an influence on smoking intensity. So either stress or years of smoking is influencing smoking intensity in some way. So with the SPSS output, the table that we look at for this is the ANOVA table. And I've highlighted to show where you find that statistic. So again, if we see that the mean square, in the mean square columns, it's the regression divided by the residual, and that gives us this F statistic. And it's significant at P equals 0.014, which is less than 0.05. So the overall omnibus F test for this regression is significant. We can say that at least one of the predictors is exerting some influence on the outcome of smoking intensity. Now, the way that we interpret the p-value for this omnibus F test is that because we're talking about the hypotheses in terms of R square, we would say that if R square is truly 0 in the population, the probability of observing an F statistic of 6.28 or larger in a sample is 0.014, or a 1.4% chance. This is a small chance, right, to observe this F statistic if R square is truly 0 in the population. It would be unlikely. So that's why we determine that at least one of the predictors is significantly influencing the outcome. But which predictor is it? That's what we'll talk about in the next lecture. So this concludes the lecture on null hypothesis significance testing in multiple regression for the full model. And in the next lecture, we'll talk about testing the specific components.